We are now going to talk about graphing using X and Y intercepts. So most functions or equations are going to cross both the x-axis and the y-axis. Not all of them, but a lot of them. The point at which the function crosses the x-axis is called the x-intercept. So in this picture, -3, 0, this point is our x-intercept. And the point at which the function crosses the y-axis is called the y-intercept. So in this picture, for this line, 0, 6 is our y-intercept. If we can figure out the point at which our equation crosses the x-axis and the point at which our equation crosses the y-axis, we can easily graph our equation. So we now have learned one way to graph equations, and that's with tables, where you plug in the x value and then you solve for the y value. And we have y solved in terms of x for examples like that. Well, now we're going to learn another way to graph our equations. And this other way to graph our equations, we're going to figure out the x and y intercepts and just graph our equations by connecting the 2 points. And in order to do this, it's a lot easier if we work with standard form. So what was standard form? It's where we have our equation set up as ax plus by equals c. So you might have an equation that looks something like this. So to find the y-intercept, you're going to let x equal 0 and plug that into your equation in standard form and then solve for y. And that will give you your ordered pair 0 and whatever y is. To find the x-intercept, you're going to let your y value be 0 and plug that into your equation and figure out what x is, and that will give you an ordered pair x, comma, 0. And then these 2 points you can plot and then connect the points to have your graph. As I mentioned, it's always easiest to complete the math where you're letting x equal 0 to find y and y equals 0 to find x if you start with standard form, and I will show you why that's easier. So here's an example. We have 3x plus -4y equals -12. This equation is already in standard form. So let's start by letting y equal 0 and solve for x. This will give us our x-intercept, or where the line will cross the x-axis. So if I come up to my equation, I'm going to put 0 in the place of y. So my equation is going to look like this. 3x plus -4 times 0 equals -12. 3x equals -12. So what is x going to equal? It's going to equal -4, right? So x equals -4. It is just a coincidence, by the way, that this is -4, that x is -4, and that our coefficient on y was -4. Complete coincidence. Okay, so that gives us the ordered pair where x is -4 and y is 0. So this is where our equation crosses the x-axis, because whenever y is 0, that means that we're on the x-axis. Then for our other intercept, we need to let x equal 0 and solve for y. And that will give us our y-intercept, or where the equation is going to cross the y-axis. So this time x is going to be equaling 0. So we're going to substitute 0 in the place of x and solve for y. When we do this, we get -4y equals -12. And so what is y going to equal? 3, right? Again, coincidence that it equals the coefficient of x. It's only because this only works out because I made the problem really easy. So what's our ordered pair for the y-intercept of this equation? 0, 3, right? So x was 0 when y is 3. And whenever we have a line crossing the y-axis, x is going to be 0. So the point on the y-axis will always have x equaling 0. Now we can graph these 2 points, these 2 intercepts, negative 4, 0. 1, 2, 3, 4 is our x-intercept, and 0, 3 was our y-intercept. And you just connect those by drawing a line. And you have your graph of the equation 3x plus negative 4y equals negative 12. Now, let's talk about why the math is so easy when you're working in standard form. I'll show you a little trick that I do. I can actually come up to this equation, and if x is going to equal 0, I just ignore the whole term with the x in it, and I look at basically the equation negative 4y equals negative 12, and I can just see very quickly that y is going to equal 3. And then likewise, when I'm looking at y equaling 0, I just ignore the negative 4y. You can think of putting your finger on top of it to make it disappear, and I look at 3x equals negative 12. And of course that gives me x equaling negative 4. So if you have this equation written out, in where I've solved for y in terms of x, and here's just my step to get there, you can see it's a lot harder to do the arithmetic, so it just takes more time. I can let x equal 0 and find that y is 3. That's pretty easy, but what happens when I want y to equal 0 and I'm solving for x? That's going to take a lot more work. So it's just easier to start with your standard form of your equation to do the arithmetic. There are 3 methods to graph an equation. We've covered 2 so far. So we use the x and y table, and here's where we solve for y in terms of x to make the math easier. And this type of graphing is great for all types of graphs. It doesn't matter if the graph ends up crossing any of your axes, the y or x axis. It doesn't matter. It doesn't matter if you have a straight line. It doesn't matter what your graph looks like. Your xy table will always work. And then the next method we've learned is x and y intercepts with standard form, and this works great with any equation as long as it is going to cross both the x and the y axis, which is not all equations, but it is a lot of them. And then the last method for graphing we will learn next. Go ahead and find the x and y intercepts and graph. You should have x equaling 4 or 4, 0 for your x-intercept and y equaling 2 or 0, 2 for your y-intercept. In this next problem, go ahead and change the equation into standard form and then find the x and y intercepts and graph. Your x-intercept is negative 4, 0, and your y-intercept is 0, 4, and here's your graph. Complete the next 4 examples. I will not have the answers here to check. We will check them later.